Okay, welcome to take two of mole calculations involving titrations. We had a go at doing some mole calculation with Jamie Smith. It was a little bit slow, lasted 11.5 minutes. We want to try and make a video that's only going to be 8 minutes, so I've enlisted some help of academic scholar and Set 1 all-round genius, Alex Asif. Alex, say hello.
Hi.
Okay, so Alex is going to help us to go through titration. So to start with, Alex, what is a titration? What type of substances do we tend to react during titrations?
Solutions.
Yeah, we're going to react solutions. Okay, so it's going to be chemistry of solutions. Now, when we're looking at solutions, it's very important to know how many particles are present in a solution. So if, for example, I was to take a solution here which contained an acid, there are two things we can work out about this acid. What are the two things we can measure?
The volume and the concentration.
Correct, the volume and the concentration. Now, as soon as we know the volume and concentration, volume being the amount of stuff in here and the concentration being the ratio of acid to water, what we can work out is we can work out something called moles. If we say that moles are equal to, what are moles equal to in terms of volume and concentration?
They're equal to volume times concentration over 1,000.
So the volume times concentration over 1,000. Okay, so if we know volume and concentration, we can work out moles. If, for example, we want to work out concentration, how would we rearrange the equation?
We get concentration equals 1,000 times moles.
Yep.
Over volume.
Good. So you just rearrange the equation, moles times 1,000 divided by volume. Now, usually what we're interested in with acids and alkalis is we're interested quite often in concentration. Because, for example, if we want to know the acid rain concentration in... where do you live, Alex?
Northampton.
Yeah, if we want to know the acid rain concentration in Northampton, we do a mole calculation. If we want to work out the amount of acid in samples of aspirin, we do a mole calculation. Right, so generally what we want to do is we want to react acids with alkalis. So let's have a look at an example. Here is some acid. Here, in fact, is some HCl. And it's going to be HCl, and it's measured, we've measured it out, 25 centimetres cubed quite accurately. How would I react alkali with it? What apparatus would I use to get the alkali into the acid?
Use a burette.
Very good.
To
use a burette.
Drip the alkali in.
Ah, very good. Use a burette to drip the alkali in. So this is alkali. It's not just any old alkali. It's going to be NaOH. And what we're going to do is we're going to drip it into here. Now, how do we know the reaction is finished?
We'd put in an indicator
yes,
to tell us when
good.
the colour changes.
You put in an indicator. So, for example, there's an indicator, and as soon as that indicator colour changes, we know the alkali has been used up, so we can tell the volume of alkali. Let's say the volume of alkali is 20 centimetres cubed. Now, of course, because the alkali was something that I got from the prep room, we knew the concentration of the alkali, and the concentration of the alkali was 1 mole per decimetre cubed. Okay. Now let's have a look at this. These numbers are important. It's good, that, isn't it? And this number is important. Okay, I'll get better at that. And that number is important as well. Can you remember those? Acid 25,
yep.
Alkali 20 and 1.
Yep.
Right. So just remind me of moles is equal to
concentration times volume over 1,000.
Almost lost it there, but okay. Volume times concentration over 1,000. Good. We're reacting HCl with NaOH. What type of reaction is this? Acid plus alkali?
Neutralisation.
Neutralisation. What does it produce? Can you do me the products?
Sodium chloride,
yep.
NaCl,
yep.
and H2O.
Good. Salt plus water. Remember, that's a type of salt.
Yep.
So what we can tell, just to remind everyone, that the ratio in this equation is 1 to 1. Okay? The ratio of the reactants is 1 to 1. The reason it's 1 to 1 is because there's no numbers in front.
Yep.
Okay, remember those numbers. What was the volume of HCl?
25.
Very good. What was the volume of NaOH?
20.
And what was the concentration of NaOH?
1 molar.
1 mole per decimetre cubed. Very good. Right, so what's the first thing we can do?
We can look at the ratio to work out...
Yeah, you looked at the ratio already. What can we work out? Moles of...
HCl.
Can't do that yet.
Or NaOH.
Yeah, you need the 2 and the 2. So moles of NaOH is equal to volume, 20, times concentration, 1 divided by
1,000,
which equals 0.02. That's the moles of NaOH. Number 2, we can now work out the moles of HCl. If the moles of NaOH are 0.02, what are the moles of HCl?
0.02.
Because you know it's a 1-to-1 ratio. Good. And therefore, if we now know that the moles of HCl are 0.02, we can work out the concentration of HCl, which is what we were trying to work out, acid rain in Northampton. Concentration of HCl is equal to, what's the formula, the rearrangement?
moles times 1,000 over the volume.
Moles times 1,000 divided by volume, which is equal to 0.02 times 1,000 divided by volume. What was the volume of HCl?
25 cm cubed.
And 0.02 times 1,000 divided by 25 is equal to?
8.
Not quite there. Make Jamie feel better. It's 0.8. And we're going to try and make this work again. Oh dear. Let's go back. Have a square, shall we? There you go. There's our answer. Alex, well done. All done in 5 minutes and 42 seconds. Say goodbye to
Bye.
5Y.
Bye, 5Y.